Welcome to part 1 of 3.3 Threats to Biodiversity. As you look at the world map here, you can see that there's been great global diversity. It's difficult to quantify. It's been decreasing rapidly due to human activity. Classification of species conservation status can provide a useful tool in the conservation of biodiversity. And as you can see here, you can see the remaining populations of indigenous species as a percentage of their original populations. So here in northern Canada, we've lost very few species. Through the southwestern and midwestern United States and Canada, we've lost significant amounts of species. Here in the middle of the rainforest of Brazil, but also in the middle of the rainforest here in Indonesia and Borneo, we're still seeing good populations of animals and organisms. Australia, you can see, has been hard hit with loss of biodiversity, as has other areas, as well as the southern and northern parts of the rainforest here. So something to keep in mind as we go forward. Now, the estimates of the total number of species on Earth vary considerably depending on the model you're using. These are all based on mathematical models, which are influenced by classification issues and a lack of finance for scientific research. And it can take a lot of work to find all these species, resulting in many habitats and groups being significantly under-recorded. As you can see here, 86% of all species on land and 91% of those in the seas are yet to be discovered. And here you can see Animalia. We've discovered an awful lot of our species. There's the predicted number in Animalia. There's the number that we found. Fungi, remember, that's like the mushrooms or even the lichens and things like that. And in terms of the Animalia, that can range from, say, chimpanzees or gorillas or orangutans in Borneo, all the way to various jellyfish species. If we look on the planet, we can see the current rates of species loss are far greater now than in recent past due to increased human influence, in part due to our growing ecological footprint and population sizes, and also our capacity to affect ecosystems. Now, the human activities that cause species extinction include habitat destruction, introduction of invasive species, pollution, overharvesting, and hunting. And if we look at the diagrams on the image here, you can see that the local extinctions in 2009, there were some going on around the world, but as we look forward to 2050 and then to 2080, we're seeing the areas of extinction growing, due in part to areas of high levels of habitat destruction, some cases pollution, other cases overharvesting. And remember, the habitat destruction can be destruction of a particular ecosystem to create a food ecosystem or an urban ecosystem for humans. Now, the current rate of species loss are far greater now than in recent past, and as you remember from presentation 3.02, we might be in the midst of a sixth mass extinction. And the rates of species loss are far greater now than in recent past due to increased human influence. The human activities that cause species extinction include, as we said before, habitat destruction, might be for farms, introduction of invasive species, either by accident or on purpose, pollution, that could be eutrophication, overharvesting, that would be such as in Canada, the cod fisheries, or on the west coast, the loss of sea otters, and then finally hunting. And if you look here, we can see a breakdown of the known causes of animal extinctions, 39% to species introduction, 36% to habitat destruction, hunting to 23%. And if you're looking at the graphic, take a look and see what appears to be the most significant cause of extinction. And it looks like it's almost a close tie between habitat destruction and species introductions. Now, what the class is doing, and what you should try doing, is putting down an example for each of the categories that you see on the PowerPoint here, whether it be habitat destruction, invasive species, pollution, overharvesting, or hunting. And I'll give you a chance to try that now. Now, moving forward, something else to bear in mind is there may be some information overload here, and so we're going to break things down into more manageable bits. Now, the International Union of Conservation of Nature, IUCN, so that's the IUCN, you may be asked about that on the exam, publishes data in the red list. So the red list of threatened species. And they have several categories for threatened. Factors used to determine the conservation status of a species include its population size, how specialized it is, where it's distributed on the planet, its reproductive potential, so how fast can it reproduce, and also its reproductive behavior, geographic range on the planet, degree of fragmentation, how much of its population is broken into smaller bits, the quality of its habitat, its trophic level, and the probability of extinction. Now, let's go forward, and you can see in Nova Scotia, they talk about species in Nova Scotia being endangered, threatened, vulnerable, extirpated, so it's extinct here in Nova Scotia, such as the eastern wolf, but not extinct everywhere, and then finally extinct is a species that no longer exists. For the IUCN, they've got least concern, no threat, data deficient, vulnerable, endangered, critically endangered, extinct in the wild, so it would exist still in zoos or game parks, and then finally extinct. Now let's take a look at what this looks like in a graphic. Here we can see that extinct and extinct in the wild, we flip the chart now. Here are the threatened categories that we're dealing with. Critically endangered, endangered, vulnerable, so it's a yellow, orange, red. And in terms to do this, we have to have adequate data and evaluate it. In other areas, we don't have enough data, and we might not even know a species existed and went extinct. Note, these categories are conservation species. They differ from the factors determining the conservation status. So again, we've got extinct, extinct in the wild, critically endangered, endangered, vulnerable, then near threatened, and least concern. In this chart, we can see a summary of these statistics, and we can see groups that have been comprehensively assessed. You can see that in terms of gastropods, very low worries. That's like shelled animals. If we look at, for example, sharks and rays, in some areas they just don't know enough, though other species are doing fine in there. Reforming corals, some are endangered, other unknown. In terms of birds and mammals, you can see there's much less unknown with birds. Mammals, a little bit unknown. Many birds are not threatened. And then you can just see overall how the areas have the most and least concerns. And then we can see there's particular groups that the amphibians, the selected reptiles, the cycads are having trouble there. Now, if we look at this chart, there's a lot going on. And what we want to see is that population size, small populations are easiest to wipe out. Degree of specialization, if you're very specialized, you're more vulnerable. Distribution, widely distributed species are more likely to survive a local habitat disturbance. Reproductive potential, high reproductive rates means you have more offspring, so you can survive disturbances and bounce back. The right whales in Nova Scotia have a low reproductive success, in that sense, reproductive potential rather. Geographic range and degree of fragmentation. Intact habitats spread over a large geographic area are less likely to be entirely wiped out by humans or even just a catastrophic event. Quality of the habitat. High quality of habitats provide ample nutrient and energy pathways to counteract local disturbances. Trophic level. There are fewer apex predators and tertiary consumers who survive disturbances. The farther up you are up the food chain and the food ladder, the tougher it can be for you to survive a disturbances lower down. Finally, the combination of these factors can make some species more naturally vulnerable to extinction. Now, if you watch this slide in a PowerPoint viewer, each point will pop out, and that way you can, in a sense, predict what each might mean or how it relates if you want to do that to review. That ends part